Welcome to Romeo's technical presentation. My name is Minya. As the project manager and team leader, I am very proud to give you this speech on behalf of my team. In this video, we will quickly go through the technical aspect of our online simulation and our soccer team. This diagram shows the structure of our online web application. The following slides will describe why we choose them and what role they play in our system. Firstly is the RoboCup soccer server. This is where the simulation takes place. This server is published by RoboCup Soccer Simulation Liege, and we are currently using version 16.0.1, which is the latest version. For database, our choice is MongoDB, which satisfies our requirements such as storing users' information and metadata that will be required for the computation simulation. Since our system does not require complex schemas in database, MongoDB is more than enough for fulfilling our requirements. This is also greatly supported by Node.js, which is used for our backend. For backend, our system uses Node.js with Express framework for development. By utilizing this framework as well as other additional packages supported by NPM, our team has successfully developed a website for online RoboCup simulation. The website provides common features including user management, real-time chat, as well as some technical features related to the tournament, like creating a competition, match streaming, recordings playback, and download. While the common features can be easily developed using packages from NPM like socket.io for live chat and passport.js for user management, etc. The detail of how those technical features are addressed will be explained later. For frontend, React.js is our choice because of its high development efficiency and excellent performance. In addition, as both React.js and Node.js uses JavaScript as its programming language, it helps reduce the cost of learning for our developers. Moreover, since the match streaming is mostly done on client side, React.js suits our requirements very well because of its high speed. For system development, we use Nginx as a reverse proxy and load balancer to deploy our web application. This slide illustrates the workflow of our system. As the entrance, when users send in the start computation command to the server, they need to wait until the match ends before they can inspect it online. Having noticed that the contests on our website are not live streamed, the reason for this is that it is impossible to stream the match through RTMP since the Robo server did not support match logs in the streamable video format. To convert and process the game log, our developer designed a C++ script, which is the result of our research into Robo server source code. This script helps us to filter out non-use elements from the initial log file generated by the server and converted it into a simpler version that is able to be understood by our web server. After it is converted, its metadata will be stored in the database and will be cast onto the soccer field drawn with HTML canvas. After the client receives the log file, the frontend will handle the playback part using canvas element. This playback feature is used by both streaming function and the recording play function. In addition, we also provide a log file for our user to download. That is the end of the presentation of our web application. Now let's move on to the second part, which is our Romeo soccer team. Additional to the web application, our team also aims to provide a team that is able to participate in RoboCup. Since building a completely new team from scratch is not viable due to the lack of resources, we have chosen to develop our team based on a base team source code provided by Right Eagle. Right Eagle is established in 1998 by the Multi-Agent Systems Lab, University of Science and Technology of China. They have participated in annual competitions of RoboCup since 1999 and have won 6 world champions and 5 runners-up of RoboCup since 2005. This base team is developed by C++ programming language, which consists of various scripts that implement complex football strategy in both defense and offense. Our original goal is to further improve this strategy by adding calculations and conditions related to the football strategy as well as other teams. However, due to the complexity of the existing algorithm and the complexity of the strategy we want to implement, we couldn't achieve this goal. The main difficulty lies in algorithm, which requires a very high level of mathematical background to implement an effective position-based evaluation system. Thus, while we are able to improve some basic decision-making process of the players, that does not show enough impact on the team's result when compared with other teams. Therefore, after balancing the time and workflow, we define a strategy so-called kit strategy and use this to build our own team. What is kit strategy? I invite you to imagine a scenario that a group of kids are playing soccer. In the kids' mind, they do not care about rules, strategies, offensive or defensive. The only thing that matters to them is the ball, just as the photo on the right shows. We use that idea to build our team. Everyone chase the ball. The video on the left-hand side is one recording download from our website. Here, the yellow one is our team. You can see that the players are all chasing the ball. They are playing soccer just like kids. That is the end of this presentation. Thank you.